The last major topic we will cover in Chapter 6 is on the measurement, which patterns are interesting. How are we going to evaluate the patterns that are mined? Earlier, we have used support and confidence threshold as a guidance to mine, to prune uninteresting rules, to keep the rules with high support and high confidence. However, interestingness is a subjective measure. Using support and confidence does not really, say whether a rule might be interesting or not. If we recall, the reason we mine association rule is trying to find items that co-occur more often than usual, or to find things that purchasing A will increase the chance of purchasing B, right? Using support and confidence threshold, as we're going to show in using a few examples next, does not even achieve this good, more objective measure of A, B co-occurs more often than usual, or having A increase the chance of B. So the support confidence framework, with more studies, people have found that it could actually find some rules that are misleading. To address that issue, people think, oh, maybe we should actually borrow the idea of correlation. Correlation may actually give us better measurement of the goodness of the tool. Because if we want to say having A increase the chance of having B, then we're talking about correlation, right? However, we discovered, again, that having strong correlation does not always mean strong association, depending on how this correlation is computed, okay? So we want measures that are robust, not influenced by non-transactions, not influenced by the total number of transactions, because as you can tell that we're going to apply those measures in different transaction databases. Some may be large, some may be smaller. If the confidence, if your goodness measures actually is influenced by the total number of transactions, well, then it's hard to compare across. And non-transactions, as we're going to introduce later, can be important consideration that we're going to introduce this concept of non-transaction and the unbalanced conditional probability. So ideally, we want measures that are robust, that are not influenced by non-transactions, and not can deal with unbalanced conditional probability when probability of B on the condition of A and the probability of A on the condition of B are very different. So we're going to see some of the measures that achieve both. Along the way, we're going to introduce the concept of non-transactions and unbalanced ratio. I think it's called Inbalance Ratio, actually. So let's look at lift. So this lift was proposed as a way to measure correlation, as a way to complement support and confidence measures. Because we observed, in this case, play basketball and eating cereal among students, that revealed that playing basketball, eating cereal, if we look at the counts occurrence here, we can say that the support for play basketball and eating cereal is what? Play basketball and eating cereal 2,000 over 5,000. So our support is 40%. What's the confidence? Among all the people playing basketball is 3,000. only 2,000 eating cereal, so our support is 60.7%. This rule, if you look at this rule and look at the support and the confidence, this can be a strong rule because it has rather high support and reasonably high confidence. However, this is, if you think this is a strong rule, then you're wrong. Because if you look at the counts, overall number of students eating cereal is 75%. So all the students eating cereal is here. If we divide this number with 5,000, we get 75%. So actually playing basketball reduces your chance of eating cereal. So therefore, looking at this support and confidence does not give you enough information to assess whether this rule is good or not. Therefore, people saying that we need some correlation measures, and the lift was proposed. So lift use the joint probability and marginal probability to compute whether those two events, A and B, whether they co-occur, whether they are correlated. If A and B are two independent events, then the joint probability of A and B both happens divided by the product of the individual probability, we're going to have a lift of 1. So if lift is 1, then A and B has no correlation. If lift is greater than 1, then A and B are positively correlated. Otherwise, if lift is smaller than 1, then these two events are negatively correlated. If we use this formula and compute this basketball and cereal eating habit, we found lift is 0.998, which is less than 0. Therefore, those two events are negatively correlated. And you can do the playing basketball, not eating cereal is actually positively correlated. Okay. I also want to mention that association rule mining, although that we have used association rule mining mostly in shopping cart analysis, it can be used outside of the shopping cart. So in this example, that we actually studied the event of eating cereal and playing basket. In our police shooting examples, again, we use association rule mining to see how those attributes related to the police shooting events are correlated. All co-occurred. I need to be very, very careful using those terms. They should be associated. That's the right word to use. Besides lift, we learned earlier we can also use chi-squared to measure the correlation. So in this case, we know how to compute that. We found the chi-squared value to be greater than the critical value. So those two events should be correlated. And by examining that our real observation is 2,000 and expected observation is actually greater than 2,000, we can conclude that eating cereal and play basketball are negatively correlated. Okay. So those are the measures that we now are in our toolkits. We have confidence and supports. We have lift and chi-square. There are more. Lots of other goodness measures has been proposed. And here we're going to list some of the good ones. So all confidence is actually the minimum of the confidence of the two directions that we can generate from association rule. So it's the minimum confidence, the smaller confidence between the rule A to B and B to A. Max confidence is the maximum of between those two. And Kosinski measure takes the average of those two confidence. Cosine similarity takes the square root of the product of the two confidence. Okay, so all of those four measures falls in the range of 1 and 0. And none of those measures are influenced by total number of transactions. Soon we're going to see why this is a good characteristic for a measurement to have for association rule mining. Beyond this 4, there's even more measurements has been proposed. So now the question is, which one is good and why there are so many? At this time, we need to introduce the concept of non-transaction and non-transaction invariant measures. So the non-transactions, see, if we look at this contingency table, buying milk and buying coffee, not buying milk, buying coffee, and not buying coffee and buying milk and all that, we can see that there is a box here indicates that none of those items that of interest to us were purchased. So non-transactions are those transactions that do not contain any of the item sets that's being examined. Why this non-transaction is of interest in this discussion is because in many situations, the number of non-transactions dominate the total number of transactions. Think about in a store, in a grocery store, a lot of times the vast majority of the transactions probably don't involve milk or coffee. I could be buying socks, I could be buying slippers, I could be buying shampoos, right? So when a correlation, the correlation measure that we have examined both lift and lift and Chisquare, both of them are influenced by this box or this box. So those correlation measures actually are influenced by non-transactions. So they are actually non-invariant measures. Non-invariant measures are the measures whose values is independent from non-transactions. Okay, the set of measures that we introduced here, all conf, max conf, cool, cosine, all those. If you look at the formula, how to compute them, you will realize those are non-invariant measures. They are not affected by non-transactions. So why non-transaction invariant is a desirable characteristic in measuring association rules? We can look at this example and try to appreciate the difference. So let's look at, so we have this example shows buying milk and buying coffee transactions. So we have a set of 6 different data sets. We're going to first examine the first 4. Okay, so first get the notations. So the tilde here indicates not buying milk, and in this table the tilde becomes the bar on the top. So in this dataset 1, we have 100,000 transactions does not have either milk or coffee. So this is the number that we would fill here. And we have 10,000 transactions contain both milk and coffee. So that should be a number entered here. Okay. So let's examine the characteristics of those 4 data sets. The first data set, we can see that vast majority of those transactions, look at the 10,000 as compared to 1,000 here and 1,000 there. Vast majority of the transactions contain both milk and coffee, and way more than people buying coffee not buying milk, or people buying milk not buying coffee. People tend to buy them together. So therefore, we can say D1 shows positive, strong association between milk and coffee buying. Okay, D2, similarly, those three numbers, the first three numbers, exactly the same, right? So people buying milk also buying coffee. Very small number of people buying coffee, not buying milk. Very small number of people buying milk, not buying coffee. Okay, as compared to people who buying milk and coffee at the same time. Therefore, D2 is also shows that milk and coffee buying are highly, strongly associated. D3, what we see here is smaller number of people buying milk and coffee together, larger number of people buying milk, buying coffee but not buying milk, or buying milk and not buying coffee. Therefore, we can conclude that what D3 tells us is that in D3, milk and coffee buying are not associated. And D4, what we see is all those three numbers are the same. So the same number of people buying milk but not buying coffee, as the number of people who buying milk, buying coffee, not buying milk not buying coffee, as the people who buying coffee and milk. Therefore, we can say those two things are neutral. They don't. They're independent. Milk buying and coffee buying, they don't influence each other. So here we summarized D1 and D2 are positively associated, and D3 are negatively associated because buying milk result more people not buying coffee result in more people not buying milk. Buying milk result in more people not buying coffee than people buying milk and coffee at the same time. Okay, so now we understand the characteristics represented in those four data sets. Let's look at the measures. This measure reflects what we see in the data set. Chi-square gave us a very strong correlation in D1, but no correlation, negative correlation, actually no correlation in D2. But we know D1 and T2 should all be positively associated. Why chi-square differs so much between D1 and D2? It is because the difference was caused by the non-transaction. If you use the chi-square's formula to compute that, you will see that this non-transactions influenced the final chi-square values greatly. Similarly, lift, we see the same issue here. On this D1 and D2, we expect to see positively strong association, but lift only show strong association for D1 and no association. So lift is 1, meaning those two are independent. So again, this chi-square, both chi-square and lift, does not reflect what the data tell us by D1 and D2 data set. Look at D3. We know D3 should be negatively associated, but here we see positive numbers. So those by chi-square and lift, both of those values suggest in D3, milk buying and coffee buying are positively correlated, which again is influenced by the non-transaction. Similarly, we expect to see neutral here, but here we see positive, strong correlation. So this says when your total transaction is heavily dominated by non-transactions, chi-square and lift are not good measures. They give you very misleading scores. In contrast, all those 5 non-transaction invariant measures give us correct scores. I mean, the scores that reflect our understanding of the characteristic of the data set. So all conf have high positive correlation for the first two, and very low association score for D3, and neutral for D4. So this indicates negative correlation, this indicates neutral. And all the others, we actually covered all confidence, cosine, max confidence. We did not cover coherence, but you can look it up if you are interested. But those 5 all have the characteristic of being non-invariant. Okay, so now we have these 5 non-invariant measures. Which one of those are better than others? To answer that question, we need to look at dataset 5 and dataset 6. And also we need to introduce another concept, imbalance ratio. So the imbalance ratio takes this formula. It measures the imbalance of the 2 item set that's involved in this rule, A to B. Okay, we have item set A and item set B. If A and B looks like this, so the size of the circle indicates the support of this item set. And the overlap indicates whether there's association between these 2 sets. Okay. Looking at this formula, we can see when A and B have same support, imbalance ratio is 0, meaning those 2 item sets are balanced. So this is this situation where we have exactly the same support for A and B. No matter whether there's overlap or not, the enumerator in this equation already determined that this rule is balanced when support of A and support of B are the same. In the other extreme, when we have the support of A and support of B very different, that everybody purchasing B also purchasing A, but only a very small number of transactions containing A contains also B. Okay. In this situation, we can see the support of A and support of B are very, very different. And the denominator is reduced almost just to support of A. So that approach, that gives you value, the imbalance value approaching 1. So the higher the IR score, the more imbalanced the items this rule is. Okay. So when we look at the item set, the data set D4, D5, and D6, we see that D4 is balanced. We can see those numbers finding the support for milk and the support for coffee. Support of milk would be the sum of this and that. Sorry, support of milk is buying milk, so this number and this number, 2,000. Support for coffee, again, is 1,000 plus 1,000, 2,000. Therefore, it's balanced. Okay. And D5, by the same calculation, we can see D5 is imbalanced. The support for milk is 10,000 plus 1,000, so that would be 11,000. And support for coffee is only 1,100, right? So it's imbalanced. And D6, again, is extremely imbalanced. And because of this, in terms of balancedness, that we have found that D4 is balanced, D5 is imbalanced, D6 is very imbalanced, extremely imbalanced. And then talking about whether there is a positive association, negative association, or the association is neutral, we can again look at the buying, the co-occurrence. So here we already discussed D4 was neutral because same number of people buying and not buying milk and coffee is roughly the same. D5 is also can be considered neutral because people, lots of people buying, coffee, also buying milk, but very small number of people buying milk, also buying coffee. What we see here is we have about 1,100 transactions buying coffee. So adding this two together, we have 1,100 transactions buying coffee. Among those, 10,000 buying milk. So from coffee to milk, we have close to 90, something around 90% of confidence. But looking at people buying milk, so buying milk should adding this and this together, so it's 11,000. Among 11,000, only 1,000 buying also coffee. So therefore, in that direction, we only have a confidence of 9%. So we can see that this the confidence from A to B and B to A is very, very different. If we consider that to be neutral, because they don't occur strongly. Only when you buy one thing, the other thing would occur, but you buy the other thing, that you buy. Gosh, this is really a tongue twister. So you get my point. This does not say those two things always co-occur. It occurs when you're actually buying coffee, you have a higher chance to buy milk. But if you buy milk, you don't have a higher chance to buy coffee. So therefore, you can consider this relation is actually neutral. It's not strongly strongly associated. Similarly, D6 has the same characteristic. Only the extent is more extreme than D3. So having that understanding of how those 3 data set carries the information, D4 is balanced and neutral, D5 is also imbalanced and neutral, and D6 is very imbalanced and also neutral because they have. And you can look at this all confidence and maximum confidence. You can see the values are so very different. With that understanding in mind, then when we look at the scores, we can see that all confidence and max confidence give us very different scores on D5 and D6. The Q score gave us the neutral score, 0.5. And then we look at the imbalancedness of this, we can see that the first data set is very balanced and the D5 and D6 are very imbalanced. So the book argues that if you use calc in together with the imbalanced ratio, you get a more truthful picture of the what the data set holds. So what I want to argue is that because we're talking about interestedness of the rules, we can, as book suggested, D5 and D6 may be considered as neutral in some applications, and the calc would, the Q score could actually serve the purpose. However, in some other cases, I think we would find this very imbalanced scores with all confidence and max confidence very different, being more interesting. So it depends on your mining goals. Now you know those differences. You can pick a reasonable performance measure to evaluate your rules. Now we have reached the end of chapter 6. To summarize what we have discussed, we studied the basic concepts and the 3 major frequent association rule mining methods, a priori and FP growth, and vertical format, the E-CLAT. And we talked about a set of different pattern evaluation methods. And we, again, at this time, I would invite you to go back to look at the learning objective and see if you have mastered all those items listed in the learning objective, or if you still have questions on some of those. Post your questions. Okay, this concludes my demonstration for the evaluation methods.